Dividing radical expressions. When dividing radical expressions, you use the quotient property of radicals, and that quotient property says you can take any radical that's a fraction, and you can separate it into two parts, the numerator and the denominator. So, for instance, if you have the square root of 3/7, that is the square root of 3 over the square root of 7. And you can do this with any radical. And this helps us because a radical expression in simplest form cannot have a fraction or a radical in the denominator. To rationalize, we call this rationalizing in denominator, means to use a method which removes the radical from the bottom. So if you take a look at this example here, this square root of 7/3, that's really the square root of 7 over the square root of 3. We can't have this fraction inside, and we can't have this radical on the bottom. So we're going to get rid of that, and we're going to do that by multiplying a fraction by 1. And that 1 is some form of 1 that we can use to get rid of a radical. And so for this first example, we're going to multiply the top and bottom by square root of 3. And really we're multiplying by 1 because square root of 3 over square root of 3 is 1. And why did I choose square root of 3? I chose square root of 3 because that's what the denominator was. And that's what I want to get rid of, is the square root on the bottom. Now how does that help me get rid of the square root? Well, the square root of 3 times the square root of 3, if you remember from our last lesson about square roots and multiplying, is really the square root of 9. And so on the bottom now, we no longer have a radical because we have made it an integer. So on the top, we have to do some combining here as well. Square root of 7 times square root of 3 is the square root of 21, and we can't break that down because 3 and 7 are prime already, so it's the square root of 21 over 3. Now we no longer have a radical with a square root, or a radical with a fraction in it, or a radical in the denominator. We've made it simplified so that we don't have either one of those two things, and so that's as simplified as it needs to be, or as it gets. A radical expression is completely simplified when the radicand contains no perfect square factors other than 1, and there are no fractions in the radicand. So we don't want any fractions inside. Up here again, we don't want any fractions inside, and we don't want to leave this square root of 9. We want to change that into the 3. So we want to actually take the square root of 9. Rationalizing a variable denominator requires the same thing. So if we have the square root of 5 over the square root of x, I'm separating those so that I can use this property on this. I want to multiply this by a square root that's 1, and I want to get rid of that square root of x, so I'm going to multiply by square root of x. And so when I do that, square root of x times square root of x is the square root of x squared, which is just x on the bottom, or in the denominator. And on the top I have square root of 5 times square root of x, so square root of 5x. And again, we no longer have a fraction, and we no longer have any radicals in the denominator. Simplifying before rationalizing the denominator. Some things we can simplify first and then multiply in order to simplify or get rid of that square root. So if you take a look at the denominator on this one, we have a 3 times the square root of 20x to the third. And we can actually simplify that because 20x to the third is actually 4 times 5 times x squared times x. And again, the reason that I did x squared and x is because I want to take the square root of x squared. And so I'm going to pull out here, the square root of 4 is 2. The square root of x squared is x. I still have this 3, and I have the square root of 5x. That's all in the denominator. So what I really have is 6x times the square root of 5x in my denominator. In my numerator, I have 72, which is, if you break 72 down, that's 9 times 8. I know 9 is a perfect square. I also know that that's 4 times 2. So what I really have here is a square root of 9 times 4 times 2 times x squared times x squared. And again, I just broke that down so you could see that there are 2 x squareds here that we're going to be taking out. So we know this 9 is 3, this 4 is 2, the square root 2 stays in there, and we have the square root of x squared and square root of x squared. That's x times x, which is x squared. So what we really have here is we have 6 x squared and then times the square root of 2. Now why did we do that first? Because now we can do some nice canceling so that we can simplify this before we actually multiply both by the square root. So we're going to cancel the 6's, we're going to cancel the x's, and all we have left is x squared root of 2 over square root of 5x. And now we can apply our radical solution that we use by multiplying the top and bottom by 5x, the square root of 5x. And so when we do that, square root of 5x times square root of 5x is 5x on the bottom. On the top we have x times 2 times 5, which is 10x in the square root. And then the last step, we can still do one more simplifying, and that simplifying is we're going to cancel these x's. So our final result is the square root of 10x all over 5. One more process that we can use is if we have something like these next ones where we have a denominator that has an addition in it, we can use what we learned from multiplying binomials to solve this problem. Because if you recall, if you have, and it shows up here, a plus the square root of b and a minus the square root of b, then if you multiply those together, remember the middle terms cancel out. And I'm going to show you right here with this problem. If I multiply this by 4 minus the square root of 5, and I'm going to do it on the top and the bottom, then when I do that, we use the FOIL method or distributive property here. We do 4 times 4, and then 4 times negative square root of 5, so negative 4 square root of 5. Then 4 times the positive square root of 5, so plus 4 square root of 5. And then minus, because negative times positive is negative, square root of 5 times square root of 5. And notice what happens to that middle term here is that it cancels those square roots of 5 out. Because 4 square root of 5 and negative 4 square root of 5 equals 0. So we can cancel those out. So all we have here is 16 minus square root of 5 squared is 5. And so on the bottom then we end up with integer whole number. And so 16 minus 5 is 11. So in our denominator here, we ended up with 11. Then we have to do the distributive property with the top as well. So 3 times 4 is 12, and 3 times negative square root of 5 is minus 3 square root of 5. And again, we've taken care of that problem of denominators with square roots. And so we don't have any square roots left in the bottom when we do this, what we call conjugation. The conjugate is multiplying the positive and negative of those square roots so that we can eliminate the middle term. So one more problem here. So again, what we're going to multiply by is the square root of 3 minus 1. And we have to do that on top and bottom because we need to keep them equal, so we're multiplying by 1 here. And so then we do the distributive property. On the top, we get 2 square root of 3 minus 2, because we distribute this, 2 here. So 2 times the square root of 3 is 2 square root 3. 2 times negative 1 is negative 2. On the bottom, we do square root of 3 times the square root of 3, which is the square root of 9, which is 3. And then we do 1 times negative 1, which is negative 1. And we cancel out those middle terms, because we would have done here square root of 3 times negative 1 and square root of 3 times positive 1, and those two terms canceled out. So again, all we end up with is 2 square root of 3 minus 2 all over 2. One last step for this one. Is there anything you can simplify here? Well, if you recall factoring out, we can take a 2 out of this top term. If we take a 2 out, that's like dividing off 2. And so when we do that, we get square root of 3 minus 1, and then we're still all over this 2. And last step then is to cancel the 2's, so our final result for this is square root of 3 minus 1.